Hello and welcome to this lecture. We still have one last part for the chapter related to evaluating a single project, which is related to capitalized worth. It is when we have the period of the project tending to be infinity. So when n, the life of the project, approaches 100 years or more or tends to be infinity, we will have to calculate the capitalized worth. So if I want to define the capitalized worth, it is a special variation of the present worth. So as if I'm getting the present worth, but we refer to it as the capitalized worth. So if I'm only calculating costs, in this case, it will be referred to as capitalized cost. Where do we find this situation? When we're dealing, for example, with public projects, I want to build a bridge or a highway. When you want to determine the life of the project, you see bridges may last for 100 years, or roads may last for 150 years if we do proper maintenance. So the period of this project is infinite. It tends to become infinity. So this is the case where we see the capitalized worth. So what happens with respect to the calculations? When n tends to become infinity and I want to get the present worth or the capitalized worth, I usually apply the equation of P equals A into P knowing AIN. However, when n becomes infinity, I can replace this factor, you see this in bracket P knowing AIN, I can replace all this value with 1 over I. So P when n approaches infinity becomes P equals A over I. I want you to look here at the table of interest. Here, this is the table related to I equals 8%. Okay, if I want to look at the P knowing A column, you will see that the value, didn't we say in the equation P equals A into P knowing AIN, and I will replace the P knowing AIN factor with 1 over I. You see here what is the value? It is 12.5. And what is the value of 1 over I? 1 over 8%, it is 12.5. So what is the value here? 12.5, and you see it's related to n equals to infinity. So even if you forgot the rule, you can look at the P knowing A column. This is the P knowing A column. When n approaches infinity, you will see that the value is 12.5, which is related to the value of 1 over I. You see here the last value is 100. So when it is 100, you'll see that it's 12.49. It's approaching 12.5. So we will consider that if the life of the project is 100 years, so we can say in this case that this is a period approaching infinity. Now also I want you to look at the A knowing P column. Here at the A knowing P column, when n approaches infinity or n approaches 100 years, see the same value, 0.08. It is exactly the same as the interest rate. Here the interest rate is 8%. So it's 0.08. So what will be the value of the A knowing P when we approach the 100 years or infinity? It's exactly as the interest rate. And you will see that this is the same for all the interest rates. So if I equals to 10%, you will see that this value is 0.1. Okay, and this value is 1 over I. Let's see an example to understand the idea better. Here we have a bridge. You see bridge, okay? Mostly these are the types of projects where n approaches infinity. So it's being planned. The construction first cost is 1,900,000. Upkeep cost is 25,000. In addition to upkeep cost, we have maintenance, which happens every 8 years at a cost of 350,000 per occurrence. So every 8 years, I'm gonna pay this amount of $350,000. Now the municipality's MAR is 8% and the expected life of the bridge is 100 years. So you see, even if I tell you 100 years, you'll have to treat it as if it is infinity. what is the capitalized worth? You see, I'm not saying what is the present worth. We will have to use this term, capitalized worth of the bridge. Now, what is the capitalized worth at 8%? I will be using this equation, P equals A over I. Now, in order to apply this equation, this means that I'm gonna change all the values that I have into A. Whenever I got the value A, it will be easy for me to apply the equation P equals A over I. I will look at the values that I have. I have here annual upkeep cost of 25,000. This is already annuity. So right away, I can apply the rule P equals A over I. Now, I have a problem with this one, maintenance of 350,000 every 8 years. So it's every 8 years, so as if this is a future value. And I want to get the annuity of this future that will occur after 8 years. So I will say, if this 350,000 is a future value and I want to change it into A, so A equals F, so I will multiply it with A knowing F, 8% and 8 years because it occurs every 8 years. This is the annuity. Now I got the annuity, I can then apply the rule of P equals A over I. So what will be the overall capitalized worth? It is, remember that this is a variation of the present worth. So as if I'm getting the present, but I just give it another name. So here I have initial investment of 1,900,000 and this is already at the present, at P0. So what do I do with it? I just put it with the negative sign and add the rest of the values. Now here I have the case where all the values are costs, so the value will be all in negative. What do I have? An annuity of 25,000. As we agreed, we will be using the rule P equals A over I. So this is A over I. And this is the value of the future of the $350,000. This one, 32,900. I just put it in the equation P equals A over I. And that's it.